for today's talk, I would like to talk about. Oh, okay, thank you. Yeah. So first of all, talk about some of the new lines on horizontal to release. The first one here is AU 20-27. That's still a breeding line. The name is not official yet. This is a runner type peanut, has a high yield, medium maturity, resistant to TSWA, also is resistant to leaf spot and high lay. There's some data showing this is testing on the 2022 in Alabama UPPT test. This is the group of the new line testing about the 140 digging days, the line comparison. So you can see this line, and in terms of the year while is on the top. So you can see, second here. Okay, here is the line we have been testing here since 2017 for many years. This is like a 4-year testing data. You compare to the AU17 year-wise for the 4-year is very competitive, a little bit higher. And then we have another line. This is called AU22 37, and this is also the runner type peanut. Also, you can see the photo showing here is we are digging last year, so it's a high yield. And you can see some of the yield data presenting here is in 2022. We testing in our breeding program in the 3 locations: Tallahassee, Alabama, Bolton, Alabama, and Heartland. So you can see this line, the overall yield is quite a significant difference than the AU-APL 17, also the GO6G, and this the yield data, also the leaf spot. You can see the new line here is 4.3, AU-MPL 17 is 3.3. They are very a little bit weaker, but it's still a good performance. So these 2 lines we are going to release. Probably the first one will be this year. This one will continue doing testing. So let we move to some update about the release variety. First one is NUAPL 17. This runner type peanut, and maturity group is about 145 days, and also is a very good disease package for TSWA, leaf spot, and YMO. Also is a higher lay, very good flavor. Another one is 2021, we released the AU Berkeley. This is a Virginia type peanut, also is a higher lay and good flavor, especially suitable for boiled peanut. So, and then presenting some data here. This is the figure showing we have a lot of the Alabama peanut variety trial. This is the Overlook or in the E.V. Smith. So we do the testing here. So I just getting some data from the website. If you want to looking for the overall picture about how the performance in the Alabama for all the release variety, you can go website here. But I just showing you this is in the one location on the plant breeding unit in Tallahassee. So you can see the TSWA here, this AU17, Berkeley, and GO6G, and leaf spot. They are very similar. And also in terms of the yield, the AU17 in that trial, almost close to 7,000 acres. You compare the GO6G is 76 acres. There's a significantly different. This another trial for the variety trial in the irrigation field in the wild grass station. So you also can see the similar. The AU17 is a very performance in terms of yield. It's a pretty strong, also very high yield. And then here is the same location. This is an unirrigated land. So you can see the AU17, they still are performance very good. So what I can tell, AU17 is a very stable variety in terms of yield, no matter you are in the irrigation land or dry land. And next one is about the disease package in the 2023. We reading that's the RX index. So for the 3 diseases, the lower the number are better. So based on the committee, they recommended the TSWA for the AU17 is 10, leaf spot is 15, white mold is 15. I will believe this is one of the top variety there in terms of the disease package. So this like AU17, how many the seed size is per pound, about 617. So in terms of the seed, so if you want to like go in here is Dr. Jim Basti acreage as the bill at the beginning, the slide showing the foundation seed, like a seed acreage for the MPL17 from 900 acre in 2021, the big jump to 3,500 acre in 2022. So I believe for this year, all the farmer, if you want to grow in AU17, we should have seed supply for the AU MPL17. So next one, I would like to move to talk about the drought tolerance. I know in this project was funded by the peanut board, also the NIFA. So I know in the drought tolerance is very complex trade for the breeder. That's a big challenge. But I do believe if we're not doing in our generation, so we don't have anything there. So we have been working on the drought tolerance for many years. Now we're becoming one of the breeding objective. So I will glad to report some of the new progress on the 2022 crop science. We published the paper. The title is called "Tolerance to Middle Season Drought in Peanut Can Be Achieved by one is called high water use efficiency or high efficiency use of water." So what that means here, I will go through a little bit. And the project is, we started many years ago. The initial screening, we take the 200 different genotype like variety, also the mimical. We're doing the screening in the National Peanut Lab, the Leon Shelter. At the beginning, we just divided by 3 stages because the drought is very complex. You have a different stage, have a different drought stress. So like early season, middle season, and later season. Based on our previous research, we find the middle season drought tolerance is most important because they will highly impact the yield. So later on, we focus on the middle season. So what we do the stress is like we have 29 days, 28 days, the stress that will recover like 4 weeks. Then we have the recover stage. So based on that, we are from the 200 genotype, we're shrinking down to the 36 lines here. So we're doing in the 21, you can see in the round shot that this is a year performance under the drought stress. You can see the genotype is significantly different. Some yield over the 3,000 per acre, kilogram here, okay, per hectare here. So we find some line they still have a high yield under the drought stress. So, and then here is a photosynthesis. So you can see also there's a big differences about the photosynthesis. Photosynthesis we find is the bigger the parameter to measure the drought stress. So you can see these two lines has a high yield. Also, you have the high photosynthesis. And you find this one is low, and then also have a low photosynthesis. And this the figure is showing you the photosynthesis. You see the top line here. Those are like a GO60, NPL 17, also PI 50. We find those lines is one of the type of the drought. They have a high photosynthesis. This figure is showing you the stomata conductor here. So you can see some of the good line, good yield, also have a good stomata conductor here. Cannot move. Slides cannot move. Okay, it's moved. Okay, and then here is another parameter to looking for is delta isotope carbon here. So then we define, like I say, the AU MPO 17, also PI 50. They have a high delta value. That is called a low water use efficiency. So we define this mechanism called a water spender. And another mechanism we find in here is we have like a line A or AU 16.28. There's a low delta. There's a high water use efficiency. At the end, the conclusion here is saying the harvest index, see the delta, photosynthesis, and stomata conductor, they are very strong or positively correlation with the drought stress. That means those parameters can use to define the drought tolerance. And then we're also finding the PI 50, 2120, AUMP 17 has high yield under the drought. So also has a higher photosynthesis and a higher stomata conductor. We consider called water spender cordial. The more we find this type of variety has a more extra water, maybe due to the deeper roots. So another mechanism we find here is some strong high yield variety have a high water use efficiency. We call that type of the tolerance called a water saver. So showing that has a relatively high, but the stomata conductor is lower.